buy from, that type of thing. So this is the data set we went after. We got it wrong the first time. We were much more prescriptive and got it right the second time going through. And once you have this data compiled, now you can act on it. Now you can actually do something with it. So what do? You assess your data, right? I mean, you got all this information from all the plants. And what we did is we started combing through it. I've got external resources, internal resources that are going through all these huge inventories of PCs. And really what we've decided we needed to do was boil it down to risk, right? Because that's really what we're talking about here, especially when you talk IT policy and IT security. Risk comes up in every other sentence that you hear. And what we did was we classified every PC with a level of risk. And then we went a step further and actually classified it as to whether or not it was production risk. If I lose that computer, am I losing production? If I lose that computer, do I lose my gauge and I can't gauge parts anymore? Or do I lose the vision system that's checking for RTV bead widths? Right? So we actually went through every single PC and automated it, by the way, with the data set I showed before, and put together a risk analysis of every computer deployed in every plant around the world. Huge task, took a year to do it, but you have to start here. You have to know what your problem is. You can't go attack a problem if you don't know how big it is and you don't know what the span of that issue is. So this is the step we took. Just checking the time here. So what do? Created a plan for every computer. And here's an idea, and I took off the number of plants associated with this because I didn't want to scare too many people, but these are the kind of counts we're talking about. So this is an example of a subset of our plants. And what we're talking about here, from a network risk, USB virus risk, remediation, and obsolescence risk, thousands and thousands and thousands of computers, right? And then, like I said, we went through and prioritized a risk rating for every one of those computers. And this just gives you an idea of how big of a problem that we've been dealing with at Ford. And we're, like I said, getting close to the end game here. But it took every bit 2 years to get where we got. And one thing that's important to recognize is that, because I had a lot of discussions with senior leadership about this, they said, why do you need all those computers? Well, do you like your FIS reports that give you cycle time and JPH information? Do you like the SPC analysis on doors that's posted in the quality room at the plant? Right? Do you like this? Do you like, oh yeah, we like that stuff. Well, you got to get that data, you got to collect it, and it takes computing horsepower to do it. This problem is not going to go away. We are going to continue to deploy more and more and more intelligence in industrial control, so you have to have strong standards and you have to have security protection. All right, so that's the plant. That was the operations and engineering work stream. Now came the more enjoyable one, at least for me, was IT policy and IT security. How do we bridge the gap with our IT partners so that we're all talking the same language, that we're all identifying common issues with what we're deploying? Going back to those 7 areas I talked about before earlier in the presentation, how do we ensure that we're aligned? Because IT, manufacturing, engineering, and controls need to be speaking from the same point of view. So one of the first things we had to do was we had to agree to what's an asset. Right? Is an asset a computer? Is an asset a PLC? Is an asset an RTV dispense system? The answer to that is yes, right? And when you look at that very first statement there, hardware includes but is not limited to, that's everything we deploy with intelligence in the industrial controls environment. So as soon as you get aligned on what an asset is, then you can figure out how to take those 7 areas I was describing earlier and apply them to those assets. It took us months to get through this discussion, right? But now we have documented strategy on what defines an asset and what defines the software that runs on those assets. And if you look at it, the software we classified in 3 areas. You need software to interface to the control systems, to program and that type of thing. You need, that's number 1. Number 2 is software that runs on the computers. And then number 3 is the software that runs the machine. right? So you have to be able to classify the assets, classify the software, and classify the network infrastructure behind those assets and how they're deployed. Very difficult challenging task, but we're there. Oh, actually, I had to zoom in on that, sorry. So, what did that lead to? Well, where we're at right now is this year we will be deploying a industrial control security standard that addresses the 7 areas of compliance I talked about before. And this document here will be an extension of IT policy going forward. It'll be auditable by the auditing office, and it will make sense to controls engineers. Because when they have the 150-page policy manual they're trying to read, it's hard to make sense of that. This will make sense. Actually talking about it in my all-employee meeting this afternoon. And then we actually created, and this one scares a lot of people, but we actually created a practice around control reviews. So if you've heard in IT an ACR or an ICR, application control review, infrastructure control review, we are now going to do those on controls hardware that we're deploying in the industrial controls environment. And really what we've decided is that, again, we're going to take a risk-based approach on how we do that, but this is an arduous task for Powertrain VO and stamping to complete. So this is where we're at today. So to get to the end of the game here, where are we at? We have been deploying and will continue to deploy and maintain significantly isolated networks, which prevents external access to the control systems and allows us to control virus propagation if and when it happens. We are in the process right now of installing antivirus and malware solutions on the PCs and plants all over the world, and we are addressing remediation and obsolescence. So do you have a backup? Do you have a software backup? Do you have a hardware backup? Can you bring that machine up when it's down? And oh, by the way, if we can't, let's replace the computer. The problem with that statement is replacing the computer comes with a lot of other tales, because usually there's hardware in the backplane of the computer that has to be addressed, or other additional software. So what you think might be a $5,000 fix to a machine that has a computer turns into a $300,000 fix real quick when you've got to swap the computer out. And then, as I mentioned before, sustain the solution through the ACR and ICR process, as well as the deployment of industrial control security standard. And that's it. So I've got 2 minutes. No forecast.
Could you tell me what role you play in the industrial controls ISAC?
What is the industrial controls ISAC?
So the Information Sharing and Analysis Center as regards cybersecurity.
We haven't played a role with that organization. We have just started to connect with our own internal cybersecurity organization. So within the last year and a half, Ford formed a cybersecurity group out of World Headquarters. We are now hooked in with them. But as far as external organizations, we have not had any discussions on this topic.
You've done a terrific job setting up a set of standards. How do you propose to enforce those standards? Because it's estimated that fewer than 16% of people actually adhere to any cybersecurity policy anywhere.
It's a good question. The way I enforce our standards is by penalty of death. I'm joking. We've really never hurt anybody, but I'll answer the question 2 ways. First of all, one of the things we did out of the gate when we first started investigating this problem was we defined a PC standard. So I already had very solid control standards on the kind of architecture we deploy, how it's integrated, how we connect to our IT systems, what kind of software runs on those control systems. But what we didn't have was a computer standard. So one of the things we did in early 14 was created a very rigorous computer standard specification that is also, and I see Mike Reed here in the audience, is also the same kind of a computer design that IT's deploying. So what we did was we locked in on a standard computer with a standard software template, a standard disaster recovery package, a standard virus malware protection suite, whether it be a whitelisting product or whether it be an SCP type solution. But the sustainability is to stop letting people go buy whatever computer's in it. And then with the industrial controls security standard I showed you, as well as the ACRs and ICR processes, we'll sustain it through those mechanisms. So the idea was, okay, we go fix all this stuff that we've been deploying for 15 years. How do we prevent this problem from happening 5 years from now? Standards and policy and audits. So it will be policeable within the plants. Sorry, Eric, I know I'm running a little beyond here.
Do you address the future of looking out 5, 10, 15 years with regard to PC structure, control structure, or are you spending most of your resource just, again, legacy and compliance now?
No, it's a good question, because that's the same question the senior management's been asking me. Because the philosophy, the question I got asked in front of some very high-level individuals at Ford was, maybe your, or it wasn't even a question, it was a statement. Maybe your strategy's wrong, right? Deploying all these computers all over the place, right? Isn't there another way to do it? So what we've been looking at, my organization and my core engineering team, is backward and forward compatibility solutions for seamless upgrades. So I'll give you an example of that is that we are going to be moving towards a path where we don't want hardware in the backplane of a computer anymore. If you need to have hardware running in the backplane of a computer, put it in its own box, so that when I want to go in and replace that PC, I don't have to worry about the hardware that it's interfacing to. Give me a USB or Ethernet solution to that black box, you put your hardware in that. And when I need to go upgrade the computer or upgrade the operating system, I can do it without affecting the hardware that's involved with it. Software is still a little bit of an issue, but the right way to think about it is that we have to be able to protect our systems for a PC upgrade every 5 years. Right? Maybe even sooner in some cases. I mean, we're fighting Windows 10 deployment right now. Right? I mean, our IT community is getting ready to roll Win 10 out to all the computers that my engineers use. Problem is, and no hardship here, Raj or Siemens, but a lot of the Siemens stuff we need for legacy Siemens control systems don't run on Windows 10. So I think the big thing for us is that we're going to be trying to be less and less, or more and more hardware agnostic, right? And have a forward and backward compatibility plan that allows us to do seamless upgrades. And that may even take us down a path of having virtual PCs. Right? Because at the end of the day, you're still going to need the computer to do the work, but does the computer really have to be a physical piece of hardware connected to the machine? Those are the types of strategies that we're looking at. Yes?
You say instead of managing technology, just manage the technocracy.
Well, I think that the key thing that was breakthrough for me and a lot of my team, maybe some of my team isn't quite there yet, but you have to embrace the fact that the IT policy does have a purpose, and it's actually an extension in our case of Ford of the finance manual, right? Because in reality, if your systems can be hacked or you don't have a disaster recovery plan, the volume forecast that you said your plants can make is at risk, right? So it can't be ignored. I mean, for a long period of time, I didn't want to go fight this battle. It was Pandora's box. And I warned everybody we talked to about it. It's Pandora's box. I had IT supervisors come to me and say, hey, other people have tried to fix this problem. Good luck. I think at the end of the day, you have to embrace IT policy, but you have to be very deliberate about where you apply them to the industrial control system. That goes back to the 7 areas that I had there. To me, that has to be where IT policy extends to industrial control. So I don't think you can, in reality, ignore it. But it's good. We've tried, and here we are.